So we've been looking at the calculus of motion, and recently you were assigned this number 7, which is about particle motion. At time t, the position of a body moving along the s-axis is s equals t cubed minus 6t squared plus 9t meters. And so this function here is our position function, right? We are calling our position function s. And we're supposed to answer A, B, and C related to this function. In part A, which we'll do first, we're asked to find the body's acceleration each time the velocity is 0. So there's two things going on in this problem that we have to pay attention to. First of all, we need to know when the velocity is 0 so that we can plug it into the acceleration, meaning that I'm going to have to find the velocity function and the acceleration function. So let's do that right now. Since we know s is t cubed minus 6t squared plus 9t, we can take the derivative of s. We can do s prime of t, which equals 3t squared minus 12t plus 9, right? We just do our power rule for derivatives and constant multiple rule, and we crank that thing out. I also need to know the acceleration, so I'll get that function a of t. That's the derivative of velocity, so I'll just do the derivative again, which is 6t minus 12. So I need to find the body's acceleration each time the velocity is 0. So to find out when the velocity is 0, I set 3t squared minus 12t plus 9 equal to 0. And this is a quadratic equation, so we have really, three methods that we typically use to solve a quadratic. One is factoring, one is graphing, looking to see where it crosses the x-axis, and the other is the quadratic formula. So choose your favorite method. I'm just going to factor this one because it's pretty straightforward. If I divide everything by 3, I get t squared minus 4t plus 3 equals 0. And that factors as t minus 3 and t minus 1. And so my solutions are t equals 1 and t equals 3. These are the places where the velocity is 0. And so to finish off letter A, I'm going to compute A of 1, which is 6 minus 12, which is negative 6. That's meters per second squared. And A of 3, 2 times 3 is 12. 6 times 3 is 18, 18 minus 12, that's going to be positive 6, and that's meters per second squared. So the acceleration at 1 is negative 6 meters per second squared, and the acceleration at 3 is 6 meters per second squared. And that's the answer for part A. We found the body's acceleration each time the velocity was 0. I've used up the whole slide here, so I'll start a new screen for letter B. So in letter B, we're asked to find the body's speed each time the acceleration is 0. So we need those two functions again, the velocity and the acceleration. So let me just write those down real quick. This is letter B that we're working on. We said v of t was 3t squared minus 12t plus 9. And we said a of t was 6t minus 12. And we are going to find out when the acceleration is 0, so I have to set a of t equal to 0, meaning 6t minus 12 equals 0, and this is a linear equation. I think you'll see pretty easily that that happens at time t equals 2 seconds. So to find the speed each time the acceleration is 0, I only have one time when the acceleration is 0. I'm going to compute the speed by plugging that into the velocity and then taking the absolute value. So I need to do v of 2. V of 2 is going to be, 12 minus 24, which is negative 12, plus 9, which is negative 3. And the absolute value of negative 3 is positive 3, and that's meters per second. So we found out when the acceleration was 0, t equals 2, and we plugged that into the velocity and then took the absolute value and found that the speed was 3 meters per second at that time. Again, I used up pretty much the whole slide here, so we'll do one more slide for part C. In part C, we introduced this new, it might be new, concept called total distance traveled. We're asked to find the total distance traveled in part C by the body from t equals 0 to t equals 2. So we're taking a look at what happened over the first 2 seconds of this process. Now, total distance traveled, and I'm just going to call that t dt for now. That has a specific meaning in our problems. It means that we are going to add the forward displacement. How do you spell forward? F-O-R-W-A-R-D, forward displacement, which is positive, plus the absolute value of the backward displacement. That says backward displacement. Sorry for the scribble there. I ran to the edge of the screen. Total distance traveled is different than standard displacement. It's a combination of adding the forward displacements plus any backward displacements we take the absolute value of before we add them in. Now let me show you what I mean by this on a number line, and then we'll go ahead and do it for this problem. So let's say we have a number line. Let's just go -1, 0, 1, 2, 3. And I'm going to have a little yellow particle here. Let's say at 1 second, I start out at 1. And over the next second, I travel 2 units forward out to 3. So I go, this takes 1 second. And then in the next second, I go 4 backwards and I end up at 0. So obviously, I traveled quite a ways to get to 0, but my displacement is just -1 because displacement is only where you started minus where you ended. Excuse me, where you ended minus where you started. So our displacement would be 0 minus 1, right? That would be -1. But the distance traveled is the forward displacement of 2 plus the absolute value of the negative displacement, which was -3. And so the t dt here would be 2 forward plus the absolute value of -3, which is a total of 5 units, right? My displacement is only -1 because I started at 1 and I ended at 0. But the distance that I traveled to get to 0 is actually 5 in terms of our units. So that's how we're going to figure out the total distance traveled. For our problem, that means we have to pay attention to when we change direction. So forward and backward are important. But we've already done the work for that. In a previous part in letter A, we found out that v equals 0 at time t equals 1 and 3. Now we're going to throw out 3 because it's not in our time interval. We're going from 0 to 2. But at t equals 1, our velocity equals 0. So if I'm taking a look at the interval from 0 to 2 seconds, I know that something happened at 1 second. I stopped, right, for an instant because my velocity is 0. So it's possible I could have turned around and gone backwards. Turns out I'm not even going to worry about it. I'm just going to compute these displacements, and any of them that are negative, I'll do the absolute value. So I have to do the displacement from 0 to 1, and I have to do the displacement from 1 to 2. Remember, displacement is s of t2 minus s of t1. So I'm just going to compute these position values, subtract them, and get my displacement. So the position at time t equals 0, if you plug 0 into s, which is up here, that's just 0. At 1, I get 1 minus 6 plus 9. 1 minus 6 is negative 5 plus 9 is 4. And then at 2, I get 8 minus, was that 24? So 8 minus 24, that's negative 16 plus 9. That is, oh goodness, is that negative 7? No, it's not negative 7 because I forgot to multiply by 2 here to make it 18. So it's going to be 8 minus 24 plus 18. 8 plus 18 is 26, minus 24 is 2, so this value is 2 here. So the displacement from 0 to 1 is 4 minus 0, which is 4. So that means we were going forward all along because that number is positive. The displacement from 1 to 2 is 2 minus 4, which is negative 2. So we were going backwards, but we're going to do the absolute value there and turn that into positive 2, and that is our displacement for the second. So my total distance traveled is 4 plus 2, which is 6 meters. Total distance traveled is 6 meters. Oops, goodness, I'm trying to cross my problem out here instead of highlight it. 6 meters for our total distance traveled. And remember, total distance traveled is your forward displacement plus the absolute value of your backward displacement. And as long as I know where I stopped, I just do the displacements on each of those intervals, and I can figure out if I was going forward or backwards and decide when to take the absolute value. If it's negative, it means I went backwards, so I took the absolute value. Okay, so that's number 7. Hopefully that cleared up any questions and gave you an idea of how you're supposed to attack some of these problems. Let me know if you have any other issues. Take care.